All right, welcome back. We are OOP3200 in the fall 2020 semester, and it's week 3, part 1 of our broadcast. We're talking about C++ class operators and conversions. I always find that class operators and conversions in general, even the idea of overloading operators, is a challenging subject for some. So I'm just going to put it out there. Don't be put off. So this week what we're doing is we're talking about class operators and conversions. I've released the in-class exercise 2, which we'll be doing today in class together. I've also given you a starter project, which is just the last week's project where we're going to start from and move from there. So remember, these in-class exercises, all you do is just hand them in, and if you made a decent effort, you get your marks. It's like that simple. Okay, so Lab 2 has also been released. Again, as mentioned last week, I'm going to probably do a short video on what I'm looking for on Friday, but you have from now until Sunday to get it done, right? So you can get that done. Quiz 1 has also been released, right? Multiple choice, true, false kind of questions, randomized from a pool of questions. You get 2 attempts. It's due on Sunday at midnight. So a bunch of stuff going on this week, as we talked about last time, which is kind of in our schedule, right? So in-class exercise with 2%, C++ assignment, which is the lab, is worth 6%, and our quiz 1 is worth 5% for this week's total of 13% of your final grade. So lots of stuff going on this week, and that's what we're doing. And again, if you take a look at Lab 2 is actually based on Lab 1. So you take Lab 1, modify it, and then you get the results for Lab 2. Okay, so we'll talk about how to do that a little bit, and strategies around how to fix it. I'll talk about it in my little video on Friday. All right, so what does this PowerPoint cover? This PowerPoint largely comes from our book, which is all around C++, 4th edition. And it talks about creating class operators and what those are, and there's some alternatives we can use too, for doing operations. So when we talk about operators, think about from a class perspective. I want to define a set of operators, and I know this is kind of hard to see. I'm going to zoom in here, but you can see that if let's suppose I want to add the ability for me to subtract or add value, subtraction and addition, right? So I want to add something to something else. I have a class. Let's suppose I have a date. I want to add a date. And this whole PowerPoint talks about a date class, which is interesting. So again, if I want to add 2 dates together, or I want to add a day to a date, so let's say I want to add 5 days, and then it should give me the resulting date. How do I do it? It's more difficult. I mean, I could certainly look at each member, by using a getter and setter and having some kind of add method. So that's what I could do. I could have an add method and then pass in the days that I want to add, and I can add the days to the date, and it'll return a new date to my class. I could do that, right? But it might be more semantically readable. So when I look at something, and if I add the plus, if I add 2 things together with the plus operator, then the result will be, something that makes sense, that has meaning for us when it comes to, that kind of operation, right? So that's what you can do. You can overload any one of these groupings of operators, all right? So all the assignment operators, you can change the comma, the ampersand, and so on. So almost everything, indirection, like the pointer operator and so on, you can modify and customize any of these operators and what they do, which is kind of really awesome, right? In terms of customization, and also again, it'll read better when you do such a thing. Okay. So here they talk about the date class. The example is a date class that they bring about in your book. So I have the date, and example, I want to add 2 dates. Well, that doesn't make any sense. But if I have an integer, I want to add to a date or subtract an integer from a date, that becomes more meaningful. Again, you have to figure out that any kind of operations we want to do has to make sense, with what we're doing. So again, subtraction of two dates, and I want to figure out how many days are between two dates. That makes sense. Comparison of two dates, that makes sense. Does this date occur before or after another date, as an example? And we can use the built-in operator symbols that we talked about above to do that. And the way the format goes for any kind of overloading is like this. You have it's a function, okay, that actually goes along inside of your C++ code, and you have to use the keyword operator, right, and then the symbol next to it. So a good example would be the operator plus. That would be the function name, okay? And then or operator equal equal. So I want to make a comparison between two things. Operator plus, operator equal equal, okay? And then what I want to do, you want to make it so that you can take in another object of that type. So example, if I'm comparing two dates, I'm going to look at another date object to compare with, almost like I have the left-hand side operand and the right-hand side operand. And the operator is going to say, okay, I want to take the left-hand side, which is the current date that I'm looking at, and the right-hand side, which is the other date that I'm looking at, and then do an operation that makes sense, that has meaning, right? Because it doesn't make sense if I just add two dates together. I can't like add 2020 and 2020 to get 4040. That doesn't make any sense, right? Maybe if I want to add 5 days to a date or something, that makes sense. Or I want to subtract the difference between one date and another, that makes sense. To tell me how many days, that's what it returns, a number of days, right? So the way it normally works is you have again, what you're returning, right? So example, in an operator equal equal, you'd be returning a Boolean, true, false. Is it true? Is it equal or not, right? Then you're going to use a const with the object type. So for example, in this case, if the class is date, you'd use the date object, the date class, and then an ampersand. So a reference to that object itself. So you're passing it by reference, and then you have access to doing stuff. Okay, so I want to make this in-class exercise, I want to do it slightly differently than how we did it last time, because we kind of almost ran out of time. I'd like to work with it as we go. So what I'd like to do instead is, if you can please open up, I'm just going to go to here. If you notice on week 3, I have several sections. One of them is this in-class exercise section, where I have the in-class exercise assignment. That's where you'd be submitting the stuff we do today, a submitting area. And this is a starter, so please download this. This zip archive is based on what we did last week. So please grab this for now and download it. So do this with me. So I'm going to do the same thing. I'm going to bring up lesson 2, and I've kind of just renamed it to lesson 3. That's all I've done. Before I start, I always want to put my stuff up on GitHub. So again, to help you with what you've done, sorry, I don't know why I'm a little dry, but to help you with what you're doing, I'm going to do the same thing that you would do. Okay, so just like I talked about last time, I want to put this up on GitHub before we start, and I want to take a snapshot of my files. So the way to do that is, I'm going to go to Team Explorer here, right, and I'm going to go to Home, and I'm going to go to Changes. Oh wait, I can't do this, right? Because guess why? I haven't added my project to source control. That's really for the first part. Sometimes people will go here and they'll say, I tried to make a commit, but I couldn't do it. It doesn't allow me to. Yeah, it won't allow you to make a commit until you add your project to source control, until you identify it as a Git, a project that is being monitored by Git. So to do that, you can go to the solution level, this is one way, and go down to where it says Create Git Repository. Or you can go down on the bottom right-hand corner, and on YouTube, I might be blocking. My head might be blocking because my head sits right here in YouTube. But on the bottom right corner, right below where I am typically, there is this Add to Source Control. Okay? So, but I'm going to do it here. I'm going to go to the solution and click on Create Git Repository. So let's do that together. Okay? So, add create Git repository. Hopefully you guys are with me. Are you with me? How about that? Check marks for you're with me, X if you're not. Ryan Mukund, are you okay? Can I help? Most people are with me at this point. I'm waiting around because I want everyone to start with me. Otherwise, now if you're also if you're watching, thank you for that feedback. I think my file is corrupted or something. Okay, make sure you unzip it. Okay, you can't just go into the file and make it work with you know.
Sometimes if you just in the Solution Explorer double click on the CPPs or the H, it'll just open even though it gives an error.
Yeah, it's possible. But what you can do also is you make sure you close all these down first. If there's a bunch of documents on the top, close them all down, and then we're going to go back into our main for a second. So now that I've added it in, hopefully I think most of you are good to go. Again, if you're not, you have until tomorrow night. I made it so you can have until tomorrow night at midnight to do this exercise with me, or watch it on the video and do it then, just to give you guys a little bit of a leeway on this. For the week. So I'm going to, but obviously it's better to do it with me because then it's done. You don't have to worry about it. So I want to add this to source control. I've done it now. So I did that. And then what I want to do now is I want to go to my Team Explorer and notice that there is no other changes because right now from the first commit, Microsoft's Visual Studio 2019 has created a couple of commits for me. Okay. So I'm going to go to Solution Explorer instead, and I'm going to go, Team Explorer, Home, and I'm going to go to Sync. And again, this is assuming that you've set up your Git and GitHub in your Visual Studio properly. You can also use an external tool like SourceTree or GitKraken or something else, or even command line. I'm going to click Publish to GitHub here. You guys should know how to do this by now. And I'm going to point to the our repo, which is Durham Programmer. That's the one I'm using. And I'm going to click Publish. So this is lesson 3 that you're going to see up online in a second. And this is our starter. Okay. So again, if you're watching this later, you know, again, I would like you to take a look at it, compare your code to my code, and all that kind of stuff. One thing that I'd like you to do in your solution is please, if you go to your main.cpp, you can see that there's an area here with your name and your student ID. Some of you forgot to do this. Please do this for me. Put your name and your student ID in here to identify yourself. Again, this is an individual assignment. It's not something that you share with somebody else. All right, so last day what we had was we had this. We created a Cartesian point class, and we also had at the bottom, we had a main where we did our kind of implementation of the class, and we kind of used it to define a new point, which was origin and destination, and we actually did the, calculated the distance between these 2 points and all that kind of stuff, right? And here's Cartesian point and the implementation piece right here, okay, or the definition section. So again, declaration section and implementation section. Well, this is okay to start, but really we don't do it this way. And some of the people that I spoke with on the weekend, I kind of went, yeah, this is cool, but the way we normally do it is we split up our classes amongst 2 different files. So this is the first thing I want you to do. Let's make 2 new files, one called Cartesian point.h, the other one called Cartesian point.cpp, and split it amongst those 2 files. So I'm going to go to source files, right click, and go add class. Let's do this together. So add class. When I do that, it brings up a little dialog box, and you can type in the class name. So I'm going to type it in, Cartesian point. Okay, and it talks about 2 things it's going to add, Cartesian point.h and Cartesian point.cpp. It's kind of a one and done. Now, sometimes I got to warn you that this little dialog box fails, and that's okay. I'll show you how to do it individually as well. So if I press OK now, what it's going to do, it says class is not registered. Look at that. Cartesian point, right? And it's the class name, and all of a sudden, because I've already got it here, it failed, right? So sometimes it fails like that. Yay, awesome. This is a great place to do it manually. So I'm going to add a new item this time. Okay. So now when you go to add new item, it's the same thing, except that it's separate. Instead of me adding a new class, I can go to a header. So let's add the header in first. Let's rename the header down here to Cartesian point. .h, okay, and I'm going to add it. It's going to add it here for now, but what you can do, normally what we do is we put headers, all the .h's, inside our headers filter up here. You can also move the my console input.h in there, okay, just to give you a sense of how that works. Okay, let's add in the .cpp now. So add a new item, and this is from scratch. This is good, and we're going to add this in. It's going to be called Cartesian point .cpp, and we'll add that in. So there's the CPP part, CPP, and there's the header. Okay, the header is pretty empty, and the CPP, immediately what you should do is when you make when you want to separate this stuff, Cartesian point .cpp should include the header. So let's do that first. So include, and we want to do Cartesian point .h. Okay, it's the first thing, the first line of our Cartesian point .cpp. Are you with me? Check marks, please, because otherwise I'm going to go quick after this, and I don't want to lose you guys, right? Again, the check mark system and just the way I'm using it for the participation is just to gauge if I have to wait a little bit longer and slow down, or if I can continue. So help me out, guys. Great, thank you for that feedback. Most of you seem to be on your way. I'm seeing more check marks come up, and okay, that's good. Let's continue that. I think most of you are good. All right, so really my Cartesian point.h is what I'm going to start working on. Before I transfer anything over from main, because that's what I'm going to do, I'm going to copy paste. I want to start creating my Cartesian point.h with a guard. That's what we call it. And I'm going to call it like this. So there is one guard already, pragma once. What this does is it says, if you try to include this .h more than one time, and or if one kind of file includes it and another file includes it, sometimes without this guard, pragma once, what will end up happening is you'll have a cyclical reference. We don't want cyclical references. It will cause an error when it comes to compilation. So we add pragma once. But pragma once is Microsoft specific, okay, for MSVC. We want to make it so that it is cross-platform, so you can use your Mac or you can use your Linux machine to do this. So we want to say the following: if not defined, this is our guard, and we want to specify the class Cartesian point. And we want to separate the words, Cartesian underscore point, like this. If it's not defined, then define it, is what we're saying. It's got to be the same, by the way. Make sure you type it in the same. I'm typing it instead of copy-pasting it because I want to give you a chance to catch up. Next, we want to do an end if. And in the end if, we usually put some kind of little comment that says defined Cartesian point, right? Which is what we've done. Okay, so that's what we've done. So that is our guard, and in between the define and the end if, we're going to implement our class. That's inside here. We have our class, right? Our class is actually sitting inside main, right? I'm not going to redo this Cartesian point class, but I want to take the definition, or the declaration, which is this, and cut it out. It's going to cause errors. Don't worry about it for now. Let's just ignore. Go to Cartesian point.h and paste. Okay, so that's what I've done there. We have an error. We're going to fix this error. Don't do it now. Let's continue. And then also, what I want to do in my Cartesian point.cpp, I'm going to put the implementation or the definition of my stuff. So I'm going to go back to main.cpp, scroll all the way down to the definition section, grab all this stuff, all the way down to Cartesian point toString, cut it, and I want to go into my Cartesian point.cpp, and underneath the .h, include, paste. All right, I have some errors, and let's fix the errors first in the .h and the .cpp, and then we'll fix the errors in the main.cpp. Okay, so I want to go into the .h first. We have this toString error. Why? Or string, because we don't have string. We have to make additional defines up here happen. I'm using ReSharp or C++, and so should you. Hopefully you have, but if not, what it's telling you is we need to include a string reference. So include string. And now if you notice, if I go up, it's included string. It's also done the long using the long name standard string because I haven't put in a using statement. And like I told you when we first started, I don't like them. I prefer to use this longer way of doing things. Why? Because using is Microsoft specific, and if you're coding for cross-platform, you may or may not have access to using. Okay. Also, it's more modern and it doesn't support backwards compatibility, right? So that's why I don't use using. I use standard and the delimiter for that particular package or module. Okay. All right. So that's how I did it there. Now let's fix up the other thing. I'm just going to delete some of these comments here. We know what that this is a constructor. And same thing with accessors. I'm going to delete some of this stuff here, only because I find that, and let's make sure that it's right now. There we go. Because it's a little cluttery for me when I have all this. And, you know, this covered what we were talking about last week, and I just want to kind of make it a little bit more compact. So that's why I'm kind of doing this, right? So that we can kind of remove some lines, and then when you see it up on GitHub, you'll see less, right? There we go. That's a little bit more comfortable for me. Okay. Save. I'm going to go back to Cartesian point.cpp now and start fixing. So what else do we have a problem with? Well, we know string is also an issue. Even though we installed string inside of my Cartesian point.h, right? It seems that my Cartesian point.cpp, this here, isn't working, right? And it says standard string is what I need to put in. So let's do standard, because there is no using. So standard string is all it's looking for, all right? String stream is also something that I didn't include, right? Because we didn't define it. So standard string stream is what we want. Right there. And when we look at standard string stream, we're missing a reference, right? And the reference that we're missing is sitting in our main CPP, right? All this stuff here. This is our string stream right here. And here's our square root functionality. And here's our, all the other stuff, the exceptions and everything else that we're using, right? So limits and all that stuff. Because here we don't need any of those things. It's happening. It's not happening in my main. It's happening in there. So I want to take pretty much everything except for the standard exception. So I want to take all these three things, right? And also the IO man IP, this one, because notice that there is there a definition here for that? Oh yes, no, I'm using it. I have to leave that in there. So all this, let's say, copy it or cut it. We can just cut it out. It's also, notice it's grayed out too, right? So we don't need it, right? I'm going to take all this out. I'm going to put this in the CPP of Cartesian point up here. So up on the top, under this include, I'm going to put some other includes. And what this is going to show you is that, hey, look, it lit up. See that how this is grayed out and these two are lit up? This means that the lit up ones mean that they're being used. The grayed out one shows that it's not being used. So we'll see if we need it. So if I scroll down now, you can see that I have no more errors inside of my my CPP program. So this is like the Cartesian point CPP, Cartesian point.h. But we have errors in main, and the reason why we have errors in main is we've never included Cartesian point.h. Let's do that now. So if I do Cartesian point.h, and normally, like I said, it doesn't matter the order of includes, as long as it's included ahead of time before you use it, you're good to go. And as long as my console input doesn't depend on Cartesian point.h, and normally it wouldn't, then that's cool. But notice the standard exception is, it says it's like unused. It's an unused thing. We're going to get rid of it in a sec. All right, so now that we've done the restructuring, that's the first thing. I want to restructure my class so that my Cartesian point.h and Cartesian point.cpp are separate files. Let's run it as is right now and make sure that things are good. So again, you can run it in x86 debug or in x64. I think this project supports both. And if I click run, then we'll see in a second if we're going to get any errors and how to deal with those errors. Hey, this looks pretty good. That's a good sign. So I want to say I want to go. I want to make a 3, 4, 5 triangle. So 3 for x, 4 for y, gives me 5. It did all the calculations for me, which makes me happy. which means that what's happened is it's gone through, it's included the Cartesian point.h, which is like a vector2 object, and I'm also using my console input.h, that static class that we used last week. I'm also doing this try catch in here, and the try catch is basically checking to see if there's any errors in input, and if there is, it's correcting it. Some of you also, I encourage you guys to use the console input class from that we talked about last week inside of your lab. And I want you to say this too. If I share code with you on GitHub or in class, it is fair game to use in your lab. Okay, as long as if it's exactly a copy paste, just mention that got this code from class as an example. For the assignments, should we not use the using statement? Andre asks. The answer for me is I'm okay with it. If you really want to use using, I'm totally fine. It's not gonna if it makes it easier for you from an understanding perspective, go ahead. Okay, but I personally find that I don't need it. So, for example, this using namespace standard. If I was to take it out of my main, and I'm going to for my example, then all I'm gonna do is go down here and just put in the differences, and in ReSharp or C++ will go in and allow you to fix all those things fairly quickly, right? So, don't be too alarmed, if you have to do it. I mean, literally it's just a click, 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 and you're done, right? In fact, you can do a file find replace, and you can get all of this done in one click, kind of thing, right? But I've just done it by hand. Now that I've made those changes, so I've removed the using statement because I don't like using it. I'm also going to remove anything that I don't need. A lot of times ReSharp or C++ will make some recommendations, and it says remove all unused include directive. Let's do that. Let's remove that all unused, include directives, right? Because it's going to make my program a little bit more efficient. Okay, cool. And let's do the same thing for my Cartesian point.cpp. I've got this limits that I'm not using really, so just going here and remove all unused includes, and it'll remove this limit as well. So now we've got our bare minimum, but hey, we made some changes, time to test. So I'm going to go in here, run it again, and do that 3, 4, 5 triangle again. So 3, 4, and I get 5. Great, awesome. Now let's put this up to GitHub because we've restructured our project. And that's what I want to put up on GitHub. So again, Team Explorer, I'm going to go to Home. I'm going to go to Changes. In Changes, I'm going to say, when I click on Change, I'm going to say Restructure Project. Because that's what I really did. And I really did it this time, right? So all I did was I split up. And instead of, I don't want to make a very long commit message because it won't make any sense. I'm going to press Commit All. I'm going to go to Home, Sync, and I'm going to push this up to GitHub. Now, for those people who are watching live, but they have access to DC Connect, I'm going to go up to GitHub for a second, and I'm going to refresh. So I'm going to go back to here, and you can see that I have a Lesson 3 link up here, so you can follow along if I'm going too quickly. I'm just going to grab this, copy it, and I'm going to go into, DC Connect here. And inside of our in-class exercise, I'm going to make a new URL link, which I'm going to add in our URL, and it'll be the GitHub link for week 3. Okay. There we go. Okay. So that is our GitHub link there. So when you're following along for the in-class exercise, and if it didn't work for you, you can always grab this and continue from where I'm at. All right, so great. So that is that. Let's continue with what we're doing here. So with the lesson. So I mean, it would be nice if when we did our Cartesian points, and I'm just going to go to the Cartesian point definition, the declaration here. It'd be nice if in our Cartesian point class that we had additional functionality that we can get from today's lesson, right? For example, wouldn't it be nice if I could, instead of using the distance calculator, get distance 2, I can use the operator minus, right, to calculate the distance from one Cartesian point to another. And that's how normally we do it. If I subtract, from, let's say, 3, 4, 5, or 3, 4, my point 3, 4, I should get a distance of 5, right? So it's still going to return the same thing. It's still going to return a double because that's what my get distance things does. But I want to use an operator to do that, right? Typically what I like to do is I want to put my operators above my accessors. So usually I have my, first I put my constructors, and let's also include a destructor. So a destructor kind of looks like with the tilde sign. Let's put that in. So Cartesian point. We're not going to do anything with the destructor right now. But the destructor basically does memory cleanup, and it tells C++ how to release resources back, to the system. Notice there's a little underline here, and with ReSharp or C++, or even with Visual Studio 2019, if I go to the hammer here, it says generate implementation. I could also go to the little underline, the green underline. This is a ReSharp or C++ thing, and if I hit the light bulb, it'll say generate definition by declaration. This is a great little tool that we get from that. And then all of a sudden, boom, we've got our definition by declaration. Or the other one, I'm just going to undo this. The other one is, if I go back to .h, it might say something like, there might be another one that says, another option for here that basically brings up a little dialog box. But for now, let's just use generate definition by declaration, just so that you're with me. So this generates the actual header of the definition with the appropriate delimiter for our Cartesian point destructor. All right, we're not using the destructor right now. And notice there's a little light bulb, and the light bulb says, hey, you know what, let's use our default destructor because you're not really using it right now. And I think that's pretty good for us to do. So let's just click on this little option. What it's going to do is going to change the destructor so it looks like this, equals to default, which means this is just the default destructor. Default destructor means, even remember we didn't even have it in our .h, but it was actually there, implied in the background. Now we're specifying, because maybe later on in this series of labs we're going to go through here and we're actually going to do something with the Cartesian point destructor. For now, no. So that's the first thing we can do. Also notice that there are some underlines and some suggestions inside here as well. So if I kind of go here and I go to my little light bulb, what is it suggesting? It says apply clang tidy fix for CPP core guidelines prototype member init. Okay, so if I click onto that, then what it's going to do is if I go back to my Cartesian point.h, right, you don't really notice a difference, all right, right now. There's nothing that's changed. But and notice also here I've got this little underline, okay? I'm just fixing my problem. So it says apply clang tidy fix for trivially destructible. So what does that do? It actually does this, and I don't like that. I like to separate my implementation from my definition, my declaration. So I don't like this. It's saying it's trivially destructible, so you don't care about making it in the CPP. I do, so I'm going to undo that change. Remember, you can always accept or not accept any of the suggestions that are made here, and with the little underlines. The little underlines here for my getters, as an example, it's also telling me, hey, rename to something else, because that is the way my linter works, and I can fix that later. We're not going to do that. But there's other ones that are really good ideas. For example, get distance to, it says that my point to, right, should be a rename to point to. I think that's pretty good because that is a standard way of doing things, point to. All right, let's do that. Let's rename it to point to. So point_2 for parameters. So that renames it. And by the way, don't worry, it renames it everywhere. Okay, that's the first thing. ToString, it doesn't like the fact that I have a capital T. It wants me to do this. I'm not going to do that. I like to keep it that way. Okay. And if I go into my Cartesian point.cpp here, notice it tells me the same thing. So say, hey, it should be renamed to set_point. I don't agree. So I'm going to leave it the way it is. Cartesian point, the whole thing is underlined for get x and get y. Why? It's probably wanting me to make it a const. And I agree with that because when I return stuff, it should be returning a constant. Let's do that. So const and const. That's a pretty good suggestion for us, right? Same thing with point to. point to, which I just changed the name of, it's probably going to ask me to make it a const. Let's add const to point to as well. Why? It's really good from a type safety perspective, right? There's another option as well. It says point to, and it says, there's another little thing. It says tidy fix for performance unnecessary value parameters. It wants to pass this thing by reference as opposed to pass it by value. Because right now what I'm doing is I'm copying the entire other object into my getDistance2 method as opposed to you copying it by reference. So if I click on this little option, it's going to add in an ampersand sign, which is now going to copy it by reference. However, and notice that it changed it automatically. So when I did this, it changed everything outside of this. Now, it may have broken something further down the line, but let's see what happens, okay? So again, I'm just accepting some of the changes from ReSharp or C++. If you don't have ReSharp or C++, it's totally cool. You can just leave it as alone. But it's a really cool little functionality that you get out of it, all right? So here's another one, int x delta, and then it does this. What this is going to suggest to me is I changed it to const, which I agree, because you're not going to do anything with it. You're not going to modify it once you have it. So I agree with that. Const int delta. Same thing with const int delta y. Delta x delta and y delta should be const because it makes sense, right? You want to add in as much type checking as possible and tooling, and you want errors to come up if you try and overwrite something like this to give you some feedback when you're doing your coding. Now that we've made these changes, it's good to check. Let's check to see if I haven't broken anything. So 3, 4, 5. We're still good. All right. So all I've done is restructure my code a little bit to comply with best practices as defined in ReSharp or C++. They're ideas. I think that they're good ideas so far. Okay. And it's more memory efficient to do it this way. Well, we're knowing if we do it this way for this const and point to for my getDistance function, chances are it's going to do the same thing for my minus function. So let's do that in the .h. So up in the .h, I want to start defining my different operator overloads. So here's operator overloads. Okay, that's what they're called. And what I want to do here is I want to define an operator that's going to return a double. Okay, we're going to use the operator keyword and the symbol minus. All right, so operator minus. We're going to define the function signature as taking a const value of a Cartesian point, right? And we're going to call this point to because we want to adhere to the new standards we just made, right? And it's going to return const. So that is our functional, our declaration for the operator minus. Notice what I'm taking in. Cartesian point, a type of Cartesian point. And then what I'm going to do is this point 2 is the right hand side. So right hand side minus the left hand side kind of stuff. Okay, be careful about what this means, point 2. Right? So this is where I'm coming from, this is where I'm going to. So 2 is on the right side. This also can be called right hand side, right? All right, cool. Operator minus, but I need to define it. So I'm going to go here. I'm going to go to my little hammer, and then I'm going to go where it says generate implementation. And if I click this, it's going to put it inside of my CPP automatically. Guys, this is fantastic. I don't have to type anything, and there's less finger typing errors than doing it by hand. Some people may say, oh, but Tom, you don't know the real, typing. You should type it by hand because if you type it by hand, it's better. No, it's not. If I can do this quicker and I don't have to worry about my copy paste problem, I'm good to go. Now it's asking me to do something here. Point to it says there's something wrong. ReSharp or C++ is saying, hey, maybe what you should do here is do something different. It says maybe you want to comment the parameter name. Okay, remove the parameter name. It says so if I comment the parameter name, it says this because the parameter name here isn't really required, right? I'm going to undo that change. Okay, so let's go back. The other one is it says remove the parameter name. Just remove it altogether because again, it's not required. I don't care what it's called on the other side. I'm never going to see that. There's no need for that. Undo. We'll put it back for a second. So that's the other change that ReSharp is recommending. It also says apply clang tidy fix for performance unnecessary value parameter, because this is going to be passed by value. I don't want that. I want it to be passed by reference again, just like further down. I think this one is a good one to put in. Let's do this one. And now you can see what it does. It adds an ampersand, and it's unused. This is not really required, but it's there. So this, my friends, is the changes that I made, and this changes the signature on in my Cartesian point.h. So notice that now it also has an ampersand, because I want to pass it by reference rather than by value. And it's a better way of doing things, absolutely, for sure. All right. So now that I have that, right, how do I define my operator minus? Well, let's take a look at down here and see what we've done for my get distance to. You know, in many ways, it should be identical, no? Because it's exactly what we're doing. We're getting the distance to from 2, and this is called, I made it 0.2 for a reason, so it's easy for us to do. Let's just lift this code out from here, copy it, and put it inside of my operator minus. So it looks identical because it is identical. There is no difference, right? In fact, this might be a more semantic, meaningful thing than, you know, distance to, right, kind of thing. Are you with me? Check mark if you're with me, please. So I think this is good, right? I mean, you're kind of defining the operator minus. And what we want to do here is we want to implement the changes inside of our main program, right? We want to make this work. So, you know, again, you know, you got to think about how this is going to work now compared to what we did before. So what we did before, we were using this get distance to thing, right? And it was okay, right? If I go to my main.cpp now, it was okay when I got distance to, right? So I said, hey, here's my distance. I want the distance. I want to take the origin, and I want to get the destination, and then you're going to get the difference between the destination and the origin. Okay. I mean, certainly I could do it this way, but wouldn't it make more sense if I just said, well, this is 0.2, this is 0.0, so I want to subtract 0.2 from 0.0 and get the distance. So let's rewrite this code. I'm just going to comment this out and rewrite it in the new way. I'm going to say distance is equal to origin minus destination. And now you can see that that computes. If I did that without the minus operator minus, it would just say, don't know what you mean. No idea what this does, is what it's going to say. Let's see if it actually does the same thing, though. So let's run it. And we'll say 3, and we'll say 4, and we get a 5. So the distance between 0, 0, and 3, 4. I think these are really great. I think this is, yeah, you don't need the operator minus at all, Nicholas. All you need to do is just the minus. We're actually defining what minus looks like for our class. We're defining, if I want to make a plus, adding two Cartesian coordinates together, as an example, or any other vector combination, I want to get dot product, cross product between two things. It's amazing what you can do with it, and it makes sense semantically, right? I want to imagine if I'm making a game and I want to get the direction, if you will, because vector is not just distance but direction. I can normalize the distance value that I'm getting, right? And again, I can probably get, instead of me getting the distance, I can change my minus so it actually gives me a new vector, a new point, if you will. Right now, I'm not getting that. I'm just getting the distance, and that's how I've set it up. But it's right now what we've done is we've actually replaced this whole get distance to method. We don't need it anymore, right? Because we have something that looks like this. Certainly the get distance to method makes sense to have as a backwards compatibility. If we were updating our class, I probably would throw a deprecated kind of error out, right? To kind of say that, hey, you know what? If you really want to use this, you can, but it's deprecated. Use of of get distance to is not required anymore. You'd rather do it this way. Okay? So that is the first part of our operator minus, and that's what is kind of shown here inside of, you know, the examples here. Except they're doing it with a class. You can also do comparison operators like this. If I want to compare, one a Cartesian point with another and make sure that it's exactly the same, we can do that too, right? So I want to make a comparison. Let's do that one next, okay? And let's see how that looks, right? And again, I'm presenting this to you because I want to start thinking about, as an example, more functionality for us. So how do I add more functionality to my my Cartesian point? Okay, let's do we'll do a comparison, then we'll move on. So again, going back to the .h. Actually, before we move on, we've added the operator minus. So let's go into GitHub. We're going to go to Home. We're going to go to Changes, and we're going to say added operator minus to Cartesian point. Right? So we're basically saying that we've overloaded the Cartesian minus operator. Commit all, home, sync, and push. Why? Because everything's working right now. We don't know if the next thing we're going to do is going to break our code. Right? Let's continue. Let's continue. We're going to go back into the Cartesian point.h, and now I want to add other operator overloads. Let's add in the next one. So what does this look like then, right? What will it return? Well, we know it's going to return a Boolean if I want to compare two Cartesian points. So again, bool, right? And I want to pass in operator and then equal equal. And then with operator equal equal, I want to make it const. I want to pass in a Cartesian point. Hey, let's use the ampersand again ahead of time, right? And then the other point. So I want to compare with 2 points, right? Other point or right-hand side, whatever you want to call it. And it's going to return const. We know this is the case because this is the standard way that we've saw it being used up here. So might as well let it be this way. I'm just going to use the little hammer to generate my implementation, which is going to go right underneath the other one. Okay, well, how do I compare two Cartesian points? There's no difficulty here. I'm going to say that I'm going to return if both the x coordinate and the y coordinate are matching. So it has to be if the my current point, right? So again, I'm going to say get x if get x is equal to other point dot get x, right? So if those 2 points are good, they're the same, right? If those two are the same, and I'm also going to look for if my y, if I look at my y, and if it's equal to the other point dot get y, right? If those two things are true, and I'm going to put brackets around everything, then I'm going to return true. Does that make sense? I'm comparing those two things. I'm saying, hey, if this one is equal to this one, and this one is equal to this one, because it's just x and y coordinates that I've got my Cartesian point, they both have to be equal, exactly the same. The values of those two things have to be exactly the same in order for me to return true. Otherwise, I'm going to return false. Other point up here, that comes from the right-hand side operator, right? So what this means is, how do I use this? How does this work, right? We can also rename this right-hand side if you want, RHS, right-hand side, because remember, you're doing an operation. Okay, so let's think about this. So if I go back to main, how do I use it? I would use it like this. I would say that so I want to see out something like this is so origin is equal to destination, right? And then you want to output if it's true or not. Let's see if that works. So we're going to say that we're going to output the values. We're going to say that origin equal destination, right? So we want to take this operation origin equal destination. That's going to be what we're testing, and then we're going to do a standard end line. Okay? So how did I do this? Look, this is the right-hand side. This is the other point that you're talking about, Nicholas. The other point is the other side, the other thing I'm looking at. All right? That makes sense? So it's like origin is equal destination. If this is true, it's going to return whatever this is, true or false. Let's see how that works. So if I'm going to go there, and let's try 2 points first. Let's see if it works. So 3, 4, and origin is equal to destination, 0. 0 means false. Okay? Remember, it's a 0 or 1. A Boolean can only respond 0 or 1. Even if I was to cast this thing toString, so if I said standard toString, so if I try this, as an example, so toString, right? If I tried this, even if I did this and I ran it again, right? So 3, 4, and then it's going to give me 0 still. It's still a 0 because it doesn't know. A Boolean is either a 0 or 1. Okay, let's test to see if that works. If it's equal to 0, if it's both 0, 0, 0, then origin is equal to destination 1. Yes, it is equal. Why? Because it's the same point. It starts off at 0, 0. So this kind of check is okay, right? And we can actually check if this is true, then say true, otherwise say false. I'm not going to do that here just from a time perspective. Makes sense? So that's the way we can use the operator. We can say, here's the left-hand side, here's the right-hand side, here's the operator. The left-hand side is tied in. It has to have the operator equal overloaded for the right-hand side to even work. Okay, I know it's kind of funky, but it's the same thing as this. Same idea. Left-hand side, right-hand side. Okay? Let's move back to some of the stuff we're doing up here. So if I go back to Cartesian point.h, we did the equal. We did the equal. All right, let's keep going and see what else it can do. So again, we can also compare A operator is equal to B, and that's also valid. And it has a little program here that you can follow, which shows you how to compare dates. If I have one date and I want to compare it to another date, you can see that here, this is the declaration section, and here, this is the definition section, right, as an example. And it shows you how to compare 2 dates because you're comparing both the month of the current date that you have and the month of the other date. That date 2 is actually the other date that you're comparing to, the right-hand side of the equation, okay? That's what you're doing here. And that's what this is doing. So you're saying, hey, I want to look at the other date, and if the other date's day is matching my day, and the other date's month is matching my month, and the other date's year is matching my year, then you know what? We're good. This else return false thing, not required. You don't need to do it this way. You just have a return statement like I did, right? And here's the usage. If A is equal to B, just like we have, left-hand side is equal to right-hand side. All right, so that's pretty cool. We did the minus operator. The plus operator doesn't make sense for us unless we want to add 2 points together. I want to add like 2 vectors is what I'm adding. All right, so I'm adding vector 1 to vector 2. Vector addition is different than the minus that we were using. So I'm not going to do that right now because it's the same as as what I've done with the equals. I'm using both values. Actually, let's just do it just for to give you some example. I think we still have time. So I want to make it so that I can use the now what will it return? First of all, if I want to make vector addition or Cartesian point addition, what am I returning, guys? Let's think about this. What am I returning if I'm doing vector addition or Cartesian point addition? Yes, Nicholas, a Cartesian point, another vector, right? So actually what I'm going to do is I'm going to say that it's going to return a brand new Cartesian point. My operator plus, right, is what it's going to be. I'm going to take a const Cartesian point, right? We're going to use it. We're going to pass it by reference. And we're going to say the other point or point 2, whatever you want to call it, right? Not point 2 like this, but like the right-hand side. I want to add 2 vectors. So maybe another Cartesian point, you know. So we can also call it a very short form, like, you know, 0.2, right? So 0.1 and 0.2, you know, kind of thing. It's up to you. So this is the signature again. Notice that it's slightly different than these ones. That's why I've separated them, just so that you can see. Here, I want to do declaration by definition, right? So again, I'm implementing the implementation piece. And notice what it says. It says, like, okay, I've got an underline. Let's do it. So how do I do this? I'm going to do it in one step again. I'm going to return, right? What do I return? I'm going to take 0.2, right? And I'm going to add it to 0.1 and return a new Cartesian point, right? Now, this is okay, right? But would I be modifying my own vector, my own Cartesian point here? Or would I be making it so that it modifies another, like 2 other points? Well, it's my own point, right? But I'm actually returning a new point. I'm not actually modifying the point that I have, right? So it's going to be like some kind of equation. I'm going to say, like, my new Cartesian point is equal to this Cartesian point A and plus B. These 2 Cartesian points adding together to get another one. Okay, that's how it's going to work. So in your mind, you have to kind of figure out, what do you want to do? Well, that's important too, right? So here, what I'm going to do is I'm going to say, I'm going to return these 2 Cartesian points. I'm going to say that I'm going to return the get y and get x, right? So get x. Here's get x, and I want to add it to the point that I'm going to have. Well, hear me out. I'm just formulating here when I'm typing. Okay. You know what? Let's not make it in one line, only because it might confuse you. So let's just make a new Cartesian point. So we'll say Cartesian point. We'll make it a temporary point. All right. My temporary point is going to be something that's going to be, I'm going to kind of put together. So temp point then, and I'm going to set point. My set point is going to be like this. And by the way, I could have also done it like in here, because it's a constructor. I could have just done my point in there, whatever my point is going to be, my temp point X and Y, right? But really what I'm looking for is my set X and set Y. So temp point dot set X, we'll say. I'm going to set X to taking the point X from point 2 plus my X and adding them together. So I'm going to say that get X, right? And then plus I want to get point 2 dot get X. Get X. Right? So I'm getting point 2's X and my X, adding them together and adding a new X value for temp point. And I'm going to do the same thing. I'm going to do the same thing here for the Y values. So instead of set X, I'm going to call this set Y. And I'm going to put these, just get the Y value from my getter and the Y value from the getter of point 2, add them together, and now I have temp point. And then I'm going to return it. So this returns a brand new point, which is the kind of taking the 2 vectors, adding them together, and returning a new one. So how would this look? So again, how do I use it? Going back to main.cpp, right? As an example, I want to add these 2 points together, right? No, I know that my origin is 0, 0, so we can change that. Instead of my origin being 0, 0, let's make it more interesting. We'll make my origin, you know, kind of 10 and 20, just to make it even. And when I add, I want to make if I get the distance between the 2 points, so let's just do this and get the distance to see what it looks like. So if I add those 2 things together, and if I said I want a 3 and 4, right, my distance between 3 and 4 is 17.464. That's the difference between 3 and 4 and 10, 20, those 2 vectors, right? But what I want instead is I want to also calculate not just the distance between the 2, as an example, but also what the new vector is. So I want to say that I want to get a new vector. So I want to say that Cartesian point, right? I want to make a new vector, which is going to be, you know, we'll say new Cartesian point, or we'll call it new point. And we want to take the origin, right? and I want to add in the destination. But now we're going to have a problem. Can I do this? I said, here's my new point, right? And I want to take origin plus destination, add them together to get a new point. Can I do that? I've never defined the copy constructor, and that's something that I want to do next. In order for me to have this happen, right? Sometimes what I want to do, these things will produce a new vector or a new Cartesian point, and I want to take that new Cartesian point and assign it to this new point. So for me to do this, I need a copy constructor, is what it's called, all right? So let's go back up to the Cartesian point. So what does the copy constructor look like? So let's put copy constructor. Okay. And what does it return? All right, because that's an important thing. If I want to make a copy constructor, right, what does that look like? What does that look like? Anybody have an idea? I mean, instead of me telling you, you can look. You can kind of. First of all, what do I mean by a copy constructor? Well, if you think about what I want to try and do, right? I want to make one thing equal to another thing, but I've never done that. I've never made the my point 1 equal to a reference of point 2, right? I want to kind of make one thing equal to the other thing. So in order for me to make my copy constructor, it kind of looks like this. It looks like a constructor, Cartesian point, right? I pass in a const this time, which is the other point, and it must be ampersand, and we're going to call this point 2. Okay, so this is the copy constructor. This is what the copy constructor syntax looks like. You use the Cartesian point name, that's the name of the class itself, and we're going to equate it to whatever the other point is going to be, the new point that we made. Okay, let's define this now, going back to generate implementation. And how does this work? Well, what we want is we want to say that I want to set x and set y to whatever point 2's x and y is. All right? That's what we want. So we're going to say that set x. Actually, you can use set point because set point is already there. And we can pass in point2.getx and then point2.gety. We already have that construct, so might as well use it. So this, what it does, it takes the right-hand side's values and assigns them to this particular Cartesian point. This is an example of the copy constructor. If we don't explicitly kind of indicate that the copy constructor, the way it looks, then what's going to happen is that we're going to have some random thing happen. We don't know what's going to happen. Here, we're being very explicit. All right, so now that we've done the copy constructor, this is what this looks like. We're copying from one point into our new point, right? C++ knows what we want. When we go back to here and we say, if I was just to say something like, new point is equal to origin, right? That's totally fine. We can totally do that now. Before we couldn't, right? But we want origin plus destination. We want to add those two things together, and we want to put a message out that says something like, origin plus destination is equal to, and then we want to take a standard string, standard toString, and we want to take the result of what we have in there. Actually what we want, and this is actually awesome, because we already defined the toString method for Cartesian point, we can just output new point, right, dot toString. Well, there you go. Does that make sense? Because we already have this. We already have the toString method defined. We already defined it last week, right? There's the toString method. Then might as well use it. Let's see if that works or if it fails us. And we'll put this up on GitHub. So again, we're going to have 2 points. We have 1020. That's the first point. And we're going to add in another 1020. So 1020. The distance, right, is 0. But if I add 2 points together, origin plus destination is 2040. If I had these 2 points, if I was going to add the same kind of thing together, the 2 coordinates together, I mean, it doesn't make any sense because they're the same coordinate, right? But I'm adding 2 vectors in this way. It's not really origin destination. It's almost like I have a vector and another one, and I'm adding together to get a third one. And it actually works, 2040. Now, this doesn't really work as an example when I add the same location. We're going to get a distance of 0. Well, because it's the same, here I'm doing the distance between the 2. This I'm adding to the 2 vectors together, right? Let's try it again and try other values. So let's say, for example, I want to add 3 and 4, right? Notice I'm going to get 13 and 24. That's how the addition works, right? But meanwhile, the distance between 10, 20, and 3, 4 is this. Okay, hopefully that's pretty clear for you now. So we can do different kind of operations with the operator overloads. Let's continue. And we talked about addition, how to do that. We just used a Cartesian point instead of a date type. Copy constructor is what we just which we just did. We kind of have an assignment where we do C is equal to A. We can do the same thing with the date, or in this case, our Cartesian point. We initialize C to A. Whatever the value of A was, we kind of initialize it. And this, you can see that this is the format that we just use. Base member initialization, that's interesting as well. So what this does is, if I have an argument list, this is one option, declare use an argument list of things that I want to declare. So all the list of data members, right, with initializing values, I can do that. Or 2, declare a function prototype with defaults in the class declaration section, followed by the initialization list in the class implementation section. I personally prefer this method, right, this thing right here. So how do I do that? So let's go back to our code and show you what that looks like. So instead of doing inside of my Cartesian point .h, I have this. I initialize my Cartesian point as 1, 1. That's the default values. If I don't say anything, then Cartesian point is just 1, 1, right? Yes. Yes, go ahead. Go ahead. Sorry guys. Yes, go ahead. 100 is okay. 100 is okay. Go ahead. Yeah. Sorry, guys.
No,
yes, I know. So that's the first thing. Sorry, I got lots of stuff going on today. So this is one way. Look, I've done here where it says set point X and Y, but instead of setting point X and Y here, this is okay. I can use a setter, but I could also initialize it like this. This is what initialization would look like for base class. I could say colon, and then I could specify the X value with a value of X and the Y value, right, with the value of Y. So I could do it this way as well. All right, that's what looks like for initialization, which means I never have to use set point the way it is right now. Set point is nice, but I don't have to use it. I could just leave it like this. And actually, the compiler prefers it this way from a initialization perspective. Okay, so that means I can just comment this out now. Does that make sense? Because instead of using set point, which actually does get X and get Y from my point, yeah, this is nice. Sure, set point does that, but I don't need it if I'm just initializing. If I'm initializing, I can use initializer list, which this is much better. Also notice that I have an X value and a Y value, right? So here it's giving me some hints. It says add const. Makes sense again, right? Never going to modify it, so might as well just use const here and const here. And now let's see if the changes make any sense. So if I run it, I want it 3, 4, and you can see that I got the same results. Remember, I always want to check and see if something that I've done is going to still function with what I've modified. Okay, let's put this up on GitHub. So what I've done now is I've added the addition operator and the comparison operator, right? That's what I've really done. So home, I've done other things too, but it's okay. Changes, see, these are all the things I've changed. I'm going to say added operator equal equal and operator plus to Cartesian point. Still a bit of a longer commit, but that's okay. Commit all, right? Home, sync, and push. So a nice workflow that I'm kind of getting you to do, right? Are you with me? Check marks. If you're with me, X's. If you're not, or if you're lost, hopefully you guys are all good. This is kind of nice and slow. I'm going slow for you guys. Daniel even gives me a thumbs up. Cool. I like that. Excellent. Good. All right. Most of you are on your way. All right. So this makes sense, right? And this is what this means by an initializer list. Okay. So all operator functions except for equals, brackets, and square brackets, and this thing here, which is a accessor, for a pointer accessor, may be written as friend functions. Okay, and that's okay. And so the syntax looks like this. Okay, friend, and so on. And why do I want to do this kind of thing? Sometimes it makes it easier if depending on how I'm doing the declaration. Here I'm not going to do that, but you can definitely write it as a friend. Okay. And here's an example of the operator plus function written as a friend, right? So, and again, what this allows me to do is it's the same as what I had before, but now I can have other additional. Notice I have additional inputs here, not just the date itself inside the round brackets, which is pretty cool. Sometimes also what I want to do is I want to write static functions for things that when I don't want to. So one thing I've done here is I've made operators here, right, in my Cartesian point.h, but these operators work on as an example, 2 different points. I could also make static functions to do the same thing, like dot product or a cross product, where I can't really do these operations, right? So I can have a static member that does some other operation. Okay, and we're going to come back to static members later on. Okay, so I'm going to keep going. It talks here about how methods are shared. I want to share a method, and it talks about how a month, a day, and a year, right? I have a starting address of an object, and starting address of B is B month, B day, and B year. And what's happening is there's distinct area is set aside for data members, right? And another area is set aside for getters and setters. Okay. And then you can access. This is just showing you the dot accessor for accessing methods, as an example, and any arguments that are placed in here. Again, you should know how to do this already, but it's explicitly said here in the PowerPoint. We can also use something called the this pointer, and this is again a subject of great confusion for students when they first look at it. The this pointer, I want to specify this month or this day or this year. It's implicitly done. So if I go back to my code, right, when I'm in here and I say something like get X and get Y, it's implicit that I mean the class that I'm inside right now. But we can be explicit by using the this keyword. And the way to do that is we can say star this, right? And then dot, and it's the dot get X. So this syntax, when I put this in front of it, in your mind, you should say it points to the actual class that I'm doing the operation on. This X and that point. That point, the right-hand side, this represents the left-hand side. And sometimes all we're doing here is being very explicit when we put this down here, all right? There's no difference necessarily in execution, but sometimes being very explicit this way is required, okay? Let's just save, and if I press play and to see what the differences are, so 3 and 4, you can see that I get the exact same results. So this change I just made with the star this is just an explicit way of accessing your getter and your 2 getters here, if it makes sense. Okay, so that's what this functionality is, and it gives you examples of how that works with month, day, and year. I can also specify any of my anything that's in my class that I want to activate. So for example, instead of using get X and get Y, I can specify not using the getters, but actually using the my member variables. Oh, one thing I want to change, guys, which has been really bugging me. This, my X and my Y. Notice, by the way, that there's these curly braces here. These curly braces are put in by ReSharper C++, which means initialize these to base values. Let's just take these away for a second, if you already have that. And I want to rename my X and my Y to M_X and M_Y to adhere to my guidelines for identifier best practices. So I'm just going to rename. So I'm going to go to refactor, rename, and I'm going to say M_X. And you might say, wait, why? What? Because M means member variable. I'm just going to refactor, rename. So whenever you see M_something, that means member variable. Member variable that's private. A private member variable. Okay? And it says that MX does not match the rule class and struct fields because I haven't set that up with ReSharper C++ where it would look for M_ in front of anything that's private. I'm not going to do that here, but what that does is it just sets up my guidelines so they work properly. If I go back to my Cartesian point.cpp, now that I've refactored, you can see now that it's there. My MX, I can see what that looks like. Okay. Now this is interesting. It says point to MX. I'm not really happy when I do the operator minus that way. In fact, I think that it's best that I use the getter for this one. So let's rewrite the operator minus to say point to get X. I want to use the getter, even though I don't need to. I want to use the getter for this one. Get Y. All right, because it's coming from this other, the other point. I want to use the get accessor as opposed to the directly access as data member. I don't want to ever do that. Same thing. It's good practice to do this for the distance method. The distance get to. I don't like using the private method. I'd rather use the get X, and the get Y properties. So why? You're going to say why, Tom? Why? Why would I do that? Well, because I think it's really important. It's super important to maintain encapsulation and data hiding when it comes to using your class, all right, or object-oriented programming. So if I run this now, let's make sure that that doesn't mess anything up, and we can try it out, and it shouldn't. You can see we're still getting the same values. We're still good to go. All right, so that's kind of that. We've kind of made some modifications so that it's now starting to adhere, starting to look like something that I'm happy with. You know, we have this toString method, but wouldn't it be nice if, right, we had a way of converting something to string? We're going to talk about that. And wouldn't it be nice if we also overloaded the streams? So as an example, I want to have the less than sign and the greater than sign. I want to overload those too, right? And we can use, we can do that by using the friend operator as well. Let's use a friend. Let's make it a friendly thing and do that way. Okay, so I'll explain how that works. It's like I'm using a static in this way when I use friend. Okay, that's how I think about it. So going up to this operator area, operator overloads. So what we're going to call these friend overloads. How does these friend overloads look? They look like this. We type the word friend. Okay, then we type the word, the thing that I want to overload. I want to overload standard OStream, right? That's what I want to overload, right? And the way it's going to be is I want to use the operator less than, right? So that's what I want to overload. I want to say that standard OStream, I want to pass in a reference of standard OStream, which is the out. And I also want to make a const of Cartesian point, right? That we're going to just call point. Okay, so that is the operator overload for the less than the outstream operator. That's what it's going to be. Let's do the same thing for the in stream. All right, so friend standard is stream, and then operator greater than, that's the in stream. So again, we have to put standard, right? We should really make that called in, right? And let's call this Cartesian point. Although we also probably want to make it so that it is a reference. I think that's kind of an important thing to do. And let's see if we need to make it const. Okay, so I've got a couple of them now, right? A couple of little overloads we want to make. Let's go up to the top where it says Cartesian point, and if you go to the light bulb, it says generate definitions by declarations. Now there's more than one. It's going to give me this little dialog box, and it's pointing to the ones I want. I can choose only one, or I can choose both. Again, this is ReSharp or C++. I want to click finish. And actually what it does is it creates those two definitions for me. Puts them at the bottom, and it doesn't matter where it puts them, but I prefer that they're near everything else, so I would just move them. So cut them out, and I want to put them near the other ones, all the other overloads. Right here's my other overloads, and let's put them kind of together. All right? Okay, what do you notice that's different here compared to the other ones? Notice that there isn't Cartesian point in here at all, right? And that's what friend does. It says I don't need to make it as part of the class, right? Operator minus less than and greater than is going to be used for, it's almost like an extension method. That's where I kind of look at it, okay? Or a static. So what do these things look like now when I want to overload the less than or greater than? Well, it's actually quite simple. It looks like this. So I want to make out less than. I want to cast my point as a string. Uh-oh. I can't cast my point as a string. I don't have that capability yet, but I will. Let's fix that in a second. So return out. And also, I want to, for standard string, I can't really do this yet. I can't do this thing. I could do Cartesian point toString. That is already in existence. I could do this. I could say Cartesian point, right, toString, because I have that capability, right? toString. My Cartesian point, which is the point, right? Point dot toString. I want to do that. That I can do, right? Because that outputs, right? So this is no problem. And how about for my in? So I have my in stream, right? And I want to do the same thing that I did for my out stream, right? So I want to say, well, in, I want to go into point dot my m underscore x, right? And in dot ignore, right? And I want to do in point on m underscore y, right? Does that make sense what I'm doing? And what this would do is take the inflow and align things in the x and y axis from my in stream. Again, this is a little bit more cryptic than this one. This one we know what it does. We want to output using the this operator out. So if I just use just a regular Cartesian point now, it automatically implies that I want to go toString with it, which is kind of cool, right? Okay, so how do you use this now then? Like, how does that work? Well, the great thing is I don't have to use the toString method anymore in main. So if I go to main, right down where I want to do anything that's toString, like this, new point.toString, I can just go new point. Because guess why? New point's okay because new point it's implicitly doing a toString. Same thing with anywhere where I used toString before. I can just get rid of it. So I can output an origin, which is actually nice and convenient for us, right? Because it allows me to be more semantic, right? Instead of adding additional syntax, hey, look, this makes more sense to me than the other way that we were doing it before, okay? If that makes any sense. And the same thing goes with if I want to enter a new point, right? Before we were using the, for example, I was entering a point that was different. I was using the console input, right? Console input, read integer, right? As an example. But I don't need to do that anymore, right? I can use cin for that. Standard cin. And then when I cin, as an example, I can add additional points. Let's try and do that. Let's say after we get the destination and everything else, let's add another point. Let's get another point. Let's see how that looks, right? So I can say that standard cout, and we're going to say something like, you know, maybe a \n, and then enter another point, right? And what we want is we want to put in a, we don't want to do a C standard end line. We want instead to do a standard cin, and we want to use the greater than sign to go into a new point. Let's make a new point up here. So we don't have this. We'll say, we'll call this another point. So Cartesian point, another point, right? And what we want is we want to use another point on the way in. And then let's just print it out again, right? So I want to show what that point is. We can say that, right, you entered another point. Again, not using the toString method. Okay? Does this make sense? So I enter something and then I want to output what I entered. Let's see if that works. So run. And then we're using that stuff. Okay, build errors. Yay, I love it. Okay, it says operator greater than must return a value. So let's go into that point. Did I forget to do something in here? Right? Well, yeah, right? Because what I've done is I didn't actually do anything. And look, it is listening for it an in stream, which means I got to return in. Okay, that's all I missed here. And let's try it again. Cool. 3, 4. And then ask me for another point. Let's add in. Uh-oh. Wait. How do I add in another point? Right? So how can I do 5? If I put 5 and press enter, right, then it asks me, it's waiting for another one. 5, 6. And now it says 5, 6. It doesn't really, it's not really that intuitive, but it actually works. There you go, Rose. That's why it's undefined. Standard in. So you have to use standard in. STD in. Actually, no, you don't. In your case, I'm not sure why that would be. If you're saying, if you're getting undefined there, you mean in? Mine is in up here. It has to be defined. It shouldn't be undefined at all. Okay. All right, so we've just done 2 friend operators. Let's add them in, and notice that they're different than these. It actually does not. It's not a Cartesian point, right? It's just a friend that we're making use of. So let's do that now. Let's put that up on Team Explorer. So home, and again, I want to go to changes, and I want to say added operator and operator to Cartesian point. You have to make sure that m_x you refactored renamed for you to get that. Okay, I'm going to go back to that, Nicholas. Let me just finish and then we'll come back to that. So home, sync, and push. It works everywhere else. So is that where, when we move to adding another point, so we were talking about in main, we're here, this is where you're getting your errors? Should work, right? And again, check your code with mine. So I put it up on GitHub now. Check your code with mine, please. And then we'll come back after the recording. I'll stop and then I'll go in and check your stuff with you if you stick around for 5 or 10 minutes. Okay. All right, so that is this part. I want to make sure I get through all this stuff. So we talked about this, the operator revisited. We talked about how to do the operator. So operator equals another one, right? I want to say this one is equal to this one. And again, I'm just doing the copy, kind of the copy constructor in many ways. But we can also specify which part is equal to which part. In this case, the date is quite complex. And I can also return this. So in this case, what I'm doing is I'm just returning back out the value of this object if I want one thing to equal to another thing, right? So if I say like this one is equal to that one, right? I'm passing my new date, my new, let's say, Cartesian point into my other one, right? Instead of initializing, I'm actually realigning the values. If it already has something, I can't initialize. I have to replace. This is a replacement of what I already have. Okay? So how does this work? So if I did that, for Cartesian point, then it would be another overload. Let's just make another overload. So again, what I'm returning, here it's returning date, we're returning Cartesian point, right? Operator equals, we're going to get a const Cartesian point, and what we want is the other point, right? So new point, we'll call it new point, and then when we declare definitions by declarations, right in here, we want to do something similar. We want to say that I want to generate a how it says day, month, and year. That is the day, month, and year of the current date. So it's almost like I want to say set x. I want to set x to the new point, right? And the new point dot get x. Okay, I want to mention that there's a problem here. Set x got to be with s, capital S. That's the way we set it up. And I also want to do set y, new point dot get y. So I'm getting the values of those things, and I'm setting the values as I make them equal, and I'm returning out a reference to, just like it says here, this. So I'm returning my value back out to itself. So I'm actually physically changing my my Cartesian point values. Now I'm getting some issues here, and let me show you what this looks like. So here it says operator equals should return Cartesian point ampersand, right? So is there a fix? So if I go here, it says return, change to return type. No, I don't like that. Here it tells me that it's probably going to say that I don't like how you've named new point, Tom. New point. I agree. Let's change it to this. That's going to satisfy this. But this is, it's not liking what I've done here. It's basically saying that it should return a Cartesian point, and I'm returning this. It's okay, but it's not happy. Does it make any difference when I run things? This is another point. So again, 3, 4, and then 5, 6. You can see that 5, 6 is there. 3, 4. It's still working. I'm just going through it all. We're almost done, guys. We talked about the notation and how this works in terms of data type conversions. So here, what they're talking about in the date class is if I enter a long integer like 2012, 09, 15, what we're doing here is we're serializing our date as a long integer and converting it into day, month, year by deserializing. And they have a section in here that does that. So they've overloaded the long operator. So when we want to try and cast it as long, or we enter a long, value, data type, then what I'm doing is I'm saying, hey, create a long value called YYY month, month, day, day. YYY month, month, day, day is equal to year times 10,000 plus month times 100 plus day. It serializes this value and returns the long version of the date out. So it converts it from a date type to a long type. So what you're doing here is you're overloading a cast. I want to cast to long, or I want to return long. I can do that. Okay? And the implementation is actually, I want to cast it as a long type. So an overload is just when we want to redefine an existing operator. Yes. And we can also use built into class conversion. So date, I want to return long. So there's my date type. I want to pass in my constructor. I pass in a long date, and then it converts it back into a regular date. So it actually parses the other way around. So serialize and then deserialize. This deserializes it. And it has a program here that you can follow if you were interested for how to do the date, this stuff. There's also two more things we want to talk about today. The operator parentheses and the operator square brackets. Square brackets is usually used for arrays, right? It's usually used for arrays. And what you can do is you can overload the square brackets or the round brackets as an example, and so that it takes in a different value. So how does this work? So for the operator square, which is a subscript operator, and this is the parentheses operator. So subscript operator, it can use when you have a single non-object argument is required. So let's say, for example, a value, you put a number in there, right? So I want to say the third one or the second one or whatever, and it can mean something. For example, in a date, I have 3 values, 0, 1, and 2. 0 would be the day, 1 would be the date, and 2 would be the year, right? You can actually, it's almost like you're subscripting each of the data members, if you will, in this case. You can use it for that, okay, which is kind of neat. So in our case, if we were to make use of the square brackets, we can use it for the x and y values. 0 would be the x and 1 would be the y if we want to, right? So we can return it this way. So it gives us a different way. And why would we want this? What if I wanted to cycle through each of my parameters, each of my data members? I want to cycle through them all, each one. I want to set them each one in a loop, right? And I want to do that for each of my types in some kind of initialization loop or something like that. This is a very good way of doing it by setting up an operator. Or if I want to create my own matrix, I want to do my own matrix and I want to have my own way of doing matrix addition and matrix subtraction and matrix transpose and a bunch of other stuff. I can use square brackets for this. There's many other reasons why. So here's an example of square brackets where I declare operator and I kind of pass in what type of operator I want. This is how you declare it. And then this is how you would use it. So basically saying, okay, so I'm getting in, I want to get an operator for days. Here what we're doing is we're adding days. That's how he's using it, the book. He's using it so when we enter days into square brackets, we're actually getting a number of days added as an example to the date, okay? Not accessing, but rather the days we're adding. So that's how we're the implementation. And then from usage, you would say, I want to add 284 days to my date, and then we can use the square brackets for this. So kind of a neat way of doing it, right? We've run into a bunch of programming errors that we have. Any kind of user assignment, we have to make sure that sometimes what happens is multiple assignments happen at the same time, and sometimes one assignment clashes with another one. Be careful, that can be something that we see often. And also using the star this or the this reference, sometimes these get mixed up and you get errors from that as well. So really, that's most of what I want to cover today. All right, so that covers everything we talked about in terms of type conversion and everything else. The summary just talks about all the things we talked about. There is another section here that talks about insides and outsides, and it makes a reference to this idea of a boiled egg object model, where the outside of the class is the shell. You can't really look inside. The yolk are the attributes, and the white is the behavior that are exposed, right? So this idea of an egg or a black box is another way of looking at it. Okay, so that's what this is, the supplement for this, to kind of give you an idea in your head of how classes and objects work. Okay, and it really leans towards abstraction and encapsulation. And we're going to talk next week about, kind of, again, we're going to continue to work into our object-oriented methodologies, and we're going to be talking more about OOP and kind of some of those words, what they mean. So that's what this section is. It's almost like a precursor or view into how to extend our code. And notice what we're doing next week before I leave you guys, stop recording, and when I'll stick around for questions. Next week, we're going to talk about inheritance and polymorphism. So I want to make a superclass as an example, and I want to inherit from that superclass. I'm also going to go into how to use UML a little bit, and I may have mentioned this before, but I highly recommend you download something called star UML, all right? Because one thing that C++ does not have is the ability for us to use it. Please go to staruml.io for next week. This is kind of a little bit of homework. I want to put this into our lecture area and download this app. It's a download that's free. You're supposed to buy it, but you can use it for free. Okay, I'm just letting you know, right? So for us, we're students, so it's okay for us to use it. I'm going to make a new link for us, and this is for staruml. So download staruml for next week, please, because I want to talk about what this is for us. Okay. Can we use Visio? Yes, you can, but I think there's some really great things you can do with staruml that actually does code generation for you too. All right, which is where I want to go. Not to say that Visio can't do it, but I'd like you to use additional tools. There's also other ones that are much better than this one. There's one called Visual Paradigm, and Visual Paradigm is actually perhaps the most popular and professional tool you can use to create UML diagrams. Okay, so here's Visual Paradigm, and it works nicely with your agile project management flow. Okay, so I'm not going to make you use this thing. Visual Paradigm is a little bit overkill, and there's a bit of a learning curve, right? But I think that staruml, when we start using it, is something that's really quick and easy to use, and we can talk about how to kind of use this stuff and create almost like plan classes and objects ahead of time. And to give you a preview of this, it also takes a look at existing code and kind of stores it up. So if I was to look at staruml, bear with me here for a second. So here's my staruml. That's what it looks like. And what you can do is you can use extensions. Notice it says buy or evaluate. This is a preview for next week. Then I can go to tools, and in C++ I can reverse code. I can get my code that I have already. So I can look reverse code, and I can go to where I have your stuff. So if I go to courses, Durham, and if I look at inside of my assignments, and I look at today, and I look at this area here where it has all my code, I can select that folder, and what it'll do is it'll take those classes and I can drag and drop them to create a reference. So here's Cartesian point. Take a look at that. It actually draws it out for me. It's really cool. And what I can do here is I can name this. So this is Cartesian point. And what this does, I'm just going to zoom in here so you can see it. It actually creates my a UML diagram for my class. So this is really awesome. Okay. And why do we want this? It's a visual representation of kind of all the things in my class. A couple things that are missing. Notice that there are my private instances are missing, right? And this is from CPP reverse. There's also what this does is it also creates a not just the Cartesian point class, but the .h files. Sometimes it doesn't bring in stuff normally. So what it's missing is a couple of attributes. One of them is the m_x attribute, which you can rename. We'll talk about this next week. Don't worry about it. And which is of type, again, int, if I'm not wrong. So I can say the type is int. And we also want to make it private, right? So minus means private. You guys should, from what I heard from Tom, you guys should know about this already, right? So know about not staruml, but about UML diagrams. So again, m_y, which is what we want to call this, and we can make it private. And now we have a kind of a full definition of what my class would look like. So why is this great? It's amazing because then if I want to inherit from this class before I do any code for my other classes, I can come here and I can kind of plot it out what my class is going to look like, and then the base class, this is my base class, my subclass that comes from this class, right? I can actually kind of create an association or some kind of generalization that goes from the subclass to this one, okay? And then you can actually draw out your other classes as well. So keep in mind, I may use this next week, and just from a visual tool to kind of describe what inheritance looks like, okay? If you would like to use Visio, absolutely go ahead. All right, guys, that's way more than I wanted to get done today. That's for sure. I think we went over and above and beyond what the PowerPoint looked for. So this is where we are today. Remember, just as a recap, in-class exercise 2 is due tomorrow night at midnight. So please, all I'm asking for that is just upload the example that I kind of went through in class with you today. And it's your practice. It's an opportunity for you to practice overloads and so on. And kind of and this is kind of in line with what your lab 2 is about. Okay. Quiz 1 is out and it's due Sunday night at midnight. Please make sure you complete quiz 1. Quiz 1 and in-class exercise 2, they're both individual assignments. So make sure that you do those two things separate on your own. And then your C++ Lab 2, that's out right now. It's due on Sunday, and I'll do a little bit of a little video around that on Friday to explain what I'm looking for. Okay? Any questions around that before I stop recording, and then I'll take questions from the class. All right, guys, I'm going to stop recording now, and I'll take questions from the people that are here.